everyone, welcome back to my channel. My name is Sahasra. In this video, we are going to learn about motion and time. So, let's get started. Motion and time. Motion and rest. An object is said to be in motion if it changes its position with respect to its surroundings in a given time. An object is said to be at rest if there is no change in its position with respect to its surroundings in a given time. Example, we can say that the tree is at rest and the car is in motion while we observe them over a period of time. A body may be at rest with respect to one set of surroundings and at the same time be in motion with respect to another set of surroundings. Thus, motion is relative to the observer. Example, if you see a chair in front of you, it is in rest. But if you see the same chair from moon or any other planet in the space, it is in motion because the earth moves around. This point is only for example, practically it's not possible. When we are sitting in a car, we are in rest for those persons who are traveling with us, but we were in motion for an outsider. A passenger in the aeroplane air during air travel is at rest for all other passengers, but in motion for a person who is seeing the plane from the ground. Uniform and non-uniform motion. If a body covers equal distance in equal intervals of time, it is said to be in uniform motion. If a body covers unequal distance in equal intervals of time, it is said to be in non-uniform motion. Example, car A travels 150 meters in 10 seconds, 300 meters in 20 seconds, 450 meters in 30 seconds, and 600 meters in 40 seconds. Car B travels 50 meters in 10 seconds, 90 meters in 20 seconds, 180 meters in 30 seconds, 230 meters in 40 seconds. We notice that the car A, the change in position in every 10 seconds is 150 meters, but for the car B, the change in position is not constant. Thus, the motion of car A is uniform and motion of the car B is non-uniform. Types of motion. We might have noticed that different objects move differently. Some objects move in curved path, some in a straight path, and few others in a different way. According to the nature of the movement, motion is classified into three types as follows: linear motion, rotatory motion, oscillatory motion. Linear motion. In a linear motion, the particles move from one point to another in either a straight line or curved path. The linear motion, depending on the path of motion, is further divided as rectilinear motion. The path of the motion is a straight line. Curvilinear motion. The path of the motion is curved. Few examples of linear motion are the motion of the train, football, and the motion of a car on the road, etc. Rotatory motion. Rotatory motion is the motion that occurs when a body rotates on its own axis. A few examples of the rotatory motion are the motion of Earth about its own axis around the Sun is an example of rotatory motion. While driving a car, the motion of wheels are and the steering wheel about its own axis is an example of rotatory motion. Oscillatory motion. Oscillatory motion is the motion of a body about its mean position. While a few examples of oscillatory motion are when a child on a swing pushed, the swing moves to and fro about its mean position. The pendulum of a clock exhibits oscillatory motion as it moves to and fro about its mean position. The string of a guitar, when strummed, moves to and fro by its mean position, resulting in a oscillatory motion. Slow and fast motion. We observe many objects in motion in our daily life. In some cases, objects move slowly, and in other cases, they move fast. Examples of slow motion: a snail walking on the ground, a tortoise walking on the ground, etc. Examples of fast motion: riding a bicycle, running, etc. Time. We use the word time very often in our daily life. We use the word time for different purposes. In some situations, without using the word time, we express the duration of time like so lately, so early, etc. How do we measure or estimate time? Let us do estimating time. Ravi and Krishna started for school at 8 a.m. From their houses, which are side by side. Ravi started on a bicycle and Krishna by walk. Who will reach the school first? How much early will he be compared to the other? How do you measure early or lately? Late arrival at school. You can easily estimate Ravi reaches the school early than Krishna. But to answer the question how early Ravi reached, we need to measure the time taken by both Ravi and Krishna and find the differences of time between the both the cases. For this, we need time instrument time measuring instruments like watches, clocks, etc. Nowadays, we use different instruments like electronic clocks, digital clocks, watts of clocks, etc. to measure time. A few decades ago, people used pendulum clocks that have become now rare. This is a pendulum clock. Do you know like minutes and hours, week, fortnight, month, season are also units for measuring time? Sand clock, water clock, sundial, etc. were used early instruments for estimating time. Measurement of time using stop clock. Stop clocks are used to measure time interval between occurrences of events accurately. Nowadays, we find stop clocks almost in a cell phones. In our daily life, stop clocks help measure pulse rate, etc. Apart from this, they also help us to accurately measure the times in running races, swimming races, etc. Units of time. The basic unit of time is second. Larger units of time are minutes and hours. Units of time. 60 seconds equals to 1 minute. 60 minutes is equal to 1 hour. 24 hours equals to 1 day. 365 days equal to 1 year. 10 years equal to 1 decade. 10 decades is equal to 1 century. 10 centuries is equal to 1 millennium. Speed. Many objects in the world around us are moving. To compare how fast they are moving, we need to know their speed. The speedometer in motor cars tells us how fast the car is traveling. Odometer in a vehicle shows the distance traveled in kilometer and the speedometer the speed of the journey in kilometer per hour. How to calculate the average speed? Average speed equals to total distance traveled by total time taken to travel the distance. Thus, we can define the speed of an object as the distance traveled by it in unit of time. Units of speed. Depending on the need and the content. The speed is measured in different units. Unit of speed in SI system is meter per second. Another unit commonly used for speed in kilometer per hour. 1 kilometer by hour is equal to 5 by 18 meter per second. Do you know how we got this? 1 kilometer is equal to 1000 meters. 1 hour is equal to 3600 seconds. 1 kilometer by hour is equal to 1000 meters per 3600 seconds is equal to 5 by 18 meter per second. So 1 kilometer by hour is equal to 5 by 18 meter per second. If we travel 1 kilometer in 1 hour, it means we travel 5 meters in 18 seconds. A car travels 15 kilometers in 10 minutes, 25 kilometers in 20 minutes, 38 kilometers in 30 minutes, 60 kilometers in 40 minutes. Total distance traveled by the car is equal to 60 kilometers. Time taken is equal to 40 minutes. The distance must be either in meters or kilometers and the time in seconds or hours. 1 hour is equal to 60 minutes. 40 minutes is equal to 40 by 60 hours is equal to 2 by 3 hours. Speed is equal to distance by time is equal to 60 kilometers by 2 by 3 hours is equal to 60 into 3 by 2 kilometers by hour is equal to 90 kilometers per hour. Thus, the car traveled with an average speed of 90 kilometers per hour. This is about motion and time. I hope you would like my video. Please do like, share and subscribe to my channel. Thank you.